Our poor little Pinto has a checkered past and a hazy future. On our road trip, we drove based on the engine temperature gauge more than anything else, running this thing right on the edge of, and sometimes fully into, overheating. I'm confident there were multiple factors at play, and while it's possible that the engine itself has some hidden secrets, I decided to tinker from the outside in and stubbornly hold out hope that it could be redeemed. I was always watching the intake manifold out of the corner of my eye, that distrust stemming from its rear coolant passage that may hold on to air, its propensity for loosening bolts which likely contributed to vacuum leaks, and its single-plane design that favors high RPM performance, possibly at the cost of low RPM consistency. To, at the very least, try something different, I want it off of there. We'll start by draining the engine oil, which honestly doesn't look or smell too terrible considering what it went through. I did go around and check the oil pan bolts, and while it wasn't noticeably leaking, they were, of course, hand tight. Next, out comes the fatigued distributor, and then a hose and 12 bolts are all that stand in our way. So it's not long before we're popping the manifold loose and removing it entirely. Most of the gasket ports showed some variety of damage, presumably from the manifold shifting around and engine vacuum pulling the material apart. Particularly telling is this section where there's a visible compression line left by the manifold squeezing down on a tear after the bolts were retightened. It didn't take long to find identical complaints about these Fel-Pro 1250 gaskets, so maybe those, along with Ford's vertical bolt layout, were bigger troublemakers than the manifold itself. While we're in there, we can check the cylinder head casting numbers that Ford graciously put on the undersides, admire the impressively dirty valves, and get just the tiniest little peek at the camshaft. I'm used to broken-in flat Tappa camshafts with smooth, shiny lobes, but this appears pitted? We're gonna ignore that. We're supposed to be here to change out this single-plane manifold, and it's time to see the replacement. Typically, I'd prefer a used name-brand manifold, but I wasn't able to find a decent one in the same price bracket as this knockoff, so we're gonna gamble with this budget dual-plane. It seems to be reasonably flat, and after a just-in-case cleaning and may-as-well paint job, it at least looks like a classy replacement for the dirty old one. We've also got a fresh 180-degree thermostat with a DIY bleed hole, and a cheap O-ring sealed housing that will get torqued to 14 foot-pounds. We'll switch part numbers for a fresh set of gaskets spec'd for the 1980 Thunderbird this engine came out of. The coolant ports look a little big, but what do I know? And after applying some RTV, the new manifold can be lowered into place. A new set of bolts will get tightened in a few steps, finishing with a pass at 20 foot-pounds. The rear vacuum port can be plugged, and the front coolant passage will house a temperature sender for the gauge as well as a switch for the radiator fan. Those will be cozying up next to the distributor, but I'd rather not put the old corroded unit back in there, so how about something I'm much more familiar with? This is an aftermarket conversion distributor that essentially mates a GM HEI system to a Ford engine, combining the Dizzy, ignition module, and coil into one package and eliminating an awful lot of wires. In exchange, we do have a much larger cap to contend with, so we should make sure there's room.
Well, it's very, very close, but it does fit.
So we'll tear that down, pull it out, align the engine, and drop it back in. At this point, I decided I should probably sneak a peek under the valve covers. And, as expected, we're looking at roller rockers and sheet steel baffles welded under the breather ports. The rocker arms feel nice and solid and all move as they should. The cylinder head bolts even clicked at 65 foot-pounds, so they likely haven't loosened. What did, however, was a screw in my head. I spent the rest of the night working on the wiring harness, but thinking about that minuscule glimpse of the camshaft that I had tried to gloss over, and what the heck it might mean. This continued until something snapped and I just had to know, meaning that this little voyage of discovery was about to get a lot more invasive. The alternator is the first to go, then there's the water pump pulley, followed by the front alternator bracket, the plugged heater hose, and then the New Mexico sourced water pump itself. The engine-mounted fuel pump is next, followed by the timing pointer, the gravity-retained oil dipstick tube, and the crank pulley. With the balancer bolt out of the way, on goes the puller, which we will impact all the way to victory. Just a handful of timing cover bolts remain, and the rear alternator mount while we're at it, separating us from the engine's innards. The fuel pump eccentric, upper timing sprocket, and dowel pin are all ready to go, along with the now easy to access connector for the oil pressure gauge. And now for the fun part, taking off the intake manifold that we just finished installing. Then we'll zip off both valve covers, allowing removal of the rocker arms and push rods. We'll be keeping all of this in order, just in case we want to keep all of these parts after getting a closer look. Next, out come the lifters, which all popped out with ease and appear absolutely immaculate. Finally, we'll toss the retainer aside and use a bolt as a handle to extract that iron thorn that had thoroughly wedged itself into my imagination. And turns out, imagination is all it was.
Because there is absolutely nothing wrong with this camshaft. What I was able to see under the intake looked like pitting, but no, I think that's just the grain. You can see the same grain structure up on the nose of the camshaft, where it definitely wouldn't be worn. The lobes all feel smooth, and they do check out with their neighbors, at least as close as I can measure them. I was only able to get the tiniest glimpse of the cam, and it actually led me down the wrong road here. I don't think I need to be the one to tell you this, but I screw stuff up sometimes.
I couldn't follow any markings to a clear part number, but measurements check out with what we were told, so I can make an educated guess. Alright, fun's over. Time to put my mess back together. The only change in there is going to be the 1-inch dowel pin, which was fine, but we'll cut down a 5/16 of an inch drill bit to step that up to 1 1/4 inch because more engagement is better. We'll carefully place all the lifters, push rods, and rockers right back where they came from, and set the preload at half a turn past 0 lash. Then the intake can go back on exactly as it was, and since everything's apart, we may as well paint the water pump and timing cover to match it. I was not impressed by the condition of the coolant ports on the cover though, and decided to fill in some of the deeper pockets of corrosion with JB Weld. Will it actually stay on there and do anything meaningful? Who knows. But at least we have new seals to get everything back together, hopefully without any new leaks, and once they're all in place, the cover can meet back up with the engine block. Ideally, you'd have a tool, or at least use the balancer to center it to the crankshaft, but I settled for eyeballing it and tightening the bolts a little at a time. Next to rejoin the party is the water pump, accompanied by the front alternator bracket, and after some finishing touches, the freshly repainted rear alternator mount can be bolted back on. I picked up a new dipstick set because the old tube was cut and the markings are highly suspect. And while the new tube required some alterations as well as significant bracket yoga, it at least shouldn't pop out every time you check the oil anymore. The harmonic balancer received a paint job and timing tape to make it easier to read, and to help us pull it on, we'll be using a 4-inch piece of 5/8 by 18 threaded rod, hardened washers, a coupling nut, and the telling not asking wrench. Out comes the stud and in goes the thread-locked bolt, which will torque to 80 foot-pounds using a wedged pry bar to hold the crank. Those crusty old pulleys also received a coat of paint, only some of which was over top of the dirt, and we're installing the lower one without any spacers behind it. After a test fit, it looks like a 1/16 of an inch spacer behind the water pump pulley lines it up perfectly, but we do still need to help it find center. As it turns out, 3 layers of 2-to-1 heat shrink neatly fills in that gap, and looks a lot nicer than the tape we used last time. Next up, to match our GM-style distributor that makes me feel more at home, we have a GM-style alternator. They are very similar in size and shape, with only a slightly longer case on this AC Delco to fit the built-in voltage regulator. This remanufactured unit has a sleeve insert that we can hammer out to fit Ford's 7/16 mounting bolt, and when slotted into the existing bracket, the pulley seems to line up perfectly. We do need to make room at the rear, but a bolt change just barely takes care of that.
I could slip probably 2 pieces of paper through there. Actually, scratch that, I just checked and I'm way off. You could just about get 4 pieces of paper through there.
And once we have a functional stack of spacers, the belt can go on for a test fit. Impressively, everything looks as close to perfect as we could hope to achieve, so all we need is a second point of contact to more confidently secure the alternator. This random piece of 1/8 inch thick bed frame steel should do nicely with a bit of trimming, drilling, and slotting. Simple, but hopefully effective. Once it's spaced out from the block, that lines up nicely and allows a decent range of adjustment, without smashing through the washer fluid tank. That'll get finished up with a coat of paint, and once it's settled, we'll need to block off the heater fitting at the water pump. Reusing the random piece of whatever this is from the old setup is going to be the most expedient method. With the engine nearly back together, it's about time we changed out the old oil filter, which I went ahead and cut open but found no significant chunks or contamination. With a new one spun on, we'll also reinstall the fuel pump and work out a stack of fittings that'll allow us to fit an oil pressure sender for a new gauge. We don't have that hooked up just yet, but we'll pour in some zinc and 5 quarts of 5W30, assuming that the factory Thunderbird spec of 5 quarts is correct. To move that through the engine, we'll drop in a pre-lube tool.
And now we're ready with the drill to spin up the oil pump and bring oil up to the top end. I'll try not to get it everywhere, but we'll see what happens.
Well, nothing if you don't spin it in the right direction.
Okay, there it is, and that's already dripping out. Oops.
That mess and some additional spinning does at least confirm that each and every rocker has good flow. So it's time to reinstall the valve covers, replacing one of the breather grommets while we're at it, and run the pump for about a minute to give the system a workout and test for leaks. Afterward, the dipstick reads just over max, which confirms the 5-quart capacity, and means that when we filled to the level on the sketchy dipstick,
We had almost 2 quarts more oil. I'm pretty sure we put 7 in this, which probably isn't enough extra to do any harm.
but trusting that scratched on dipstick mark definitely didn't do us any favors. Once the distributor is back in at approximately the right angle, we'll whip up a custom 6-gauge alternator cable and get back to the never-ending task of running wires. This car doesn't even have that many of them, but it is a lot to keep track of. My lack of planning was really catching up to me too, as there are several separate wire looms that really should have been joined together, but at least the number of zip ties is totally reasonable. Despite all that, I am still confident that things are getting better. We now have 2 ground cables going from the engine to studs on the body. Which might not sound, groundbreaking, but it is a lot better than the very nearly 0 engine grounds we had before. Like, seriously, I was pulling electrical tape off and the connector came with it. I'm confident that the tape, added purely for aesthetic reasons because seeing the red ground cable gave me a deep feeling of unease, was the only thing holding it to the engine. So even if my rewire is short on polish, it doesn't have to live up to much. But I haven't even started on the inside of the car, which is going to be a huge undertaking of its own. We can at least close off the wall between the two a little bit better, by making a new block-off plate for whatever this hole was, to join the existing blower motor plate. Hopefully, these will work in unison to diminish the scorching hot jet of air directed at the passenger's legs. I guess we'll find out someday when this thing is roaring down the road again, but right now we still have problems begging for some attention. One such drama queen that never fails to leave its mark is the transmission. It's the car's primary puddle maker, proven by the dense rust-inhibiting coating on everything nearby. Keeping fluid in the transmission was a constant struggle that I'd like to be done with.
Oh, that was loose. That was really loose.
I can't imagine why this was leaking.
Let's see. Yep. Yep.
The Whisper-tight oil pan bolts certainly weren't doing us any favors.
There's a fair amount of material in there. I have no idea how many miles it's been since the valve body install, other than hour 3000, but probably not a lot. I don't think this car was driven very much. Hopefully just putting Type F in there stops this from shedding and makes things a little bit better.
That wire was on there real solid.
And once we can take a good look at the filter,
It's certainly chunkier than I would prefer. At the very least, it's not magnetic.
I did want to step up the capacity of the brownie pan and picked up this plus 1 quart aluminum cheapie, which will be easy to drill and tap for pipe threads in order to mount a temperature sender. It comes with an extension that uses common Chrysler style filters, and after a quick valve body retorque, we'll bolt that on. Then up goes the filter, with lock nuts of course, and the pan fits like it was made for it.
Are you fucking kidding me? What?
Yeah, the filter extension's too long and doesn't match the angle of the pan. After confirming that the manual valve body is the same height as the original and that the fit is off by over an inch, I decided to take matters, and a hacksaw, into my own hands. In hindsight, I should have drilled out the original weld and reattached the lower section in the same way, and also ground off the plating, but after extensive sanding and cleaning, this lumpy filter standoff actually fits the pan it came with. I did manage to pull out the threads on 2 of the mounting bolts and had to switch to longer fasteners, but at least that shiny, ill-conceived pan can finally be installed. We'll torque those in a few steps to 15 foot-pounds and leave the drain plug at 25.
Okay, that only took the whole freaking day.
Nearby and equally greasy is the speedometer cable that has been desperately trying to roast itself on the exhaust. The gauge doesn't work, not that you can see it anyway, and although I have a sneaking suspicion it has to do with this gear we found rolling around under the hatch, we're going to be overhauling the dashboard and won't need a mechanical speedo, which means we won't need this slimy cable. Just 1 bolt holds that in the tail shaft housing, and, big surprise, no gear on the end of the cable to match up with the output shaft. From there, we'll pull the cable all the way into the engine bay, and, considering the overall condition, I didn't feel too bad about cutting it to simplify removal. And finally, this fancy little plug will seal off the hole we left in the housing. Don't worry though, the Pinto hasn't lost itself even with the high-dollar dress-up parts, and in fact only 1 of the 6 tailshaft housing bolts was tight, and this guy was outright missing. Once that's been rectified, over on the side of the case we have the shift lever, which...
Oh, I'm glad I checked that. That was already pretty loose.
The clamp bolt to the selector shaft was tight, but the throttle valve shaft could create a massive leak if it were to pop in too far. I'm not actually sure it can, but a DIY lock nut should make sure we don't need to find out. The shifter cable, however, has been up to no good. It appears to have slid backwards and was sitting on the drive shaft yoke. That's obviously no good, but an extra layer of protection and proper hold downs should help keep it out of harm's way. Unlike that cable, trouble inside the transmission is much harder to see, so I'd really like to have a line pressure gauge to keep track of whatever is going on in there. If you crane your neck and squint past the grime, there's a plug on the driver's side of the case capping off the perfect port for this sender. Surely finding it was the hard part, right? Oh, if only that were the case. That tiny little jerk is so stuck in there that even a tight-fitting 6-point socket rounded it off before it budged.
Oh, stripping. Shit. Well.
It's terribly awkward, but the usual solution of welding something to the plug seems like the last chance we've got. I maybe went a little too aggro on it though, and some creativity was required because a socket would no longer fit. The extreme heat did get it moving at least,
Oh yeah, I can see the base of a thread.
but soon there was a snag. I had managed to glue that nut on there off-center, and it was rubbing against the transmission case. That's already uncomfortable for the guy, but unfortunately for him and the case threads, increasing the torsion seems like our only hope. Which was looking dim after a few failed nut stacking attempts, so I went for a 3/8 bolt.
Here's the hard part, moment of truth. You can do it, come on, you're doing it, you can do it. Oh, come on, you're doing it. You broke, didn't break the weld, it twisted the bolt off.
But it seemed like we were on the right track, so sign me up for another round of burns.
Okay, you absolutely beautiful plug. Just got past the hard part. Oh, you beautiful bastard! You can do it! You're doing it! Ha! There it is.
That became quite the fiasco. Next time I should probably skip straight to the bolt. Luckily, the threads look okay, and once we flush that from the inside out, the pressure sender can finally be installed.
I hope it works.
To find out, we'll twist up some wires and run them down to it, the temp sender, and what the heck, the trans brake solenoid too, even though I don't have plans to use it. I hope the transmission is appreciating all of this attention, and I even tried to spoil the tired old guy a little by picking up a shiny new inspection cover, which is when I learned that there are different variations of the C4 bell housing.
Hey, look at that. I was mistaken. There we go. Bolts line up just fine. Of course things are that easy. They always are.
But the trans still isn't the best at keeping fluid in, and has 2 more leaks that we can do something about. The dipstick tube is hemorrhaging oil and should be easy to remove. Well, we can change out the rear seal at least. Once the drive shaft U-bolts are out of the way, we can drop that down to get access to the seal, and a puller tool makes short work of it. The new seal also has an external boot with a downward-facing vent hole, and once it's tapped into place, we are ready to reinstall the drive shaft. Or at least we would be if I hadn't noticed this when taking it out. Yeah, that universal joint is junk, and now that I know, I can't just let it slide. We're also gonna need a new set of U-bolts. Go ahead, guess which one was ready to fall off. Seriously, I can't believe this thing made it home. But it did, so it's still my problem.
Ooh, look at that.
It seems likely that this damage is from over-tightening,
I'm not tight, these are supposed to be.
but the joint seemed due for replacement anyway. This is an original Ford drive shaft out of something that's been shortened, but I suspect otherwise unaltered. To give it a bit of a refresh, we'll excavate the snap rings and pry them both out. The factory staked these in place, so they put up a bit of a fight. A washer will help spread out the load that the ball joint press is going to apply, and then the joint just needs to be finessed out of the yoke.
It smells burnt. There was a lot of heat in here for sure. There's also a lot of slack between the rollers. They're probably just smaller than they used to be.
I guess when the whole car shakes all the time and fails to reach posted speed limits, it is pretty hard to notice the type of driveline vibration that this would have caused. The front joint still feels solid, but we should probably go ahead and change both. We'll press it out of the slip yoke, and then the drive shaft yoke just like the rear one. Both joints are relatively small 1310s, but for the car's weight and power level, it doesn't seem worth a size upgrade. What I will do, however, is clean the drive shaft up. I grew to be displeased with its caked-on layers of filth, but a thorough wire wheeling and coat of paint spiffed that up nicely. We'll also use Scotch-Brite with our elegant bench polisher, aka a shop towel over a socket and a zip tie on the trigger, to give the slip yoke a nice shine. And here's the new jewelry to go along with it. These are common, aftermarket greasable U-joints. With lightly oiled bores on the yoke, we'll carefully slot one of those in with a pair of caps removed, line up one cap and get it moving using the vise, then bring in the second and make sure the joint floats freely in the middle to hold the rollers in place. With those started, we'll use the ball joint press to push the first cap below the snap ring groove. The first ring was a very snug fit, and after pressing the second cap all the way in, I realized that we've got a problem. These raised spots where the factory staked in the original joints are adding just enough thickness that I can't get the clip fully installed. So out comes the U-joint and in goes the Dremel. After removing the dimples with the underside of a cutting disc, this time we have a joint that is fully buckled in and moving freely. After a touch-up, the drive shaft side of that universal joint goes together in the same way, and only then did I figure out that there wasn't enough room for the grease fitting on that side. So yeah, let's flip that around. Only I wasn't as careful this time and became a textbook example of why you need to keep the rollers in place. Yep, I obliterated one, and with it trashed the entire part. But hey, look, new stuff! We're changing brands because I wasn't impressed with the finish work on the Moog joints, and we need all the help we can get since my screwing around seems to have taken its toll on the drive shaft side bores. After a light sanding to remove the high spots, the caps didn't fit as tight as I'd like. See how I can press them in partway by hand? Ideally, you wouldn't be able to do that, so we'll break out the bearing retainer for extra insurance against one spinning. But I don't expect we'll have any problems, and it does still take the press to fully assemble both axes of the joint anyway. Once it's moving freely while not smashing the grease fitting, it's finally time to install the rear joint. You know, the one that was actually bad and kicked all of this off. I hope this driveline drama has been a useful lesson for someone in how not to do things. It certainly was for me. As one last little pick-me-up, how about we fix something that wasn't my fault? The drive shaft isn't the only thing that connects the transmission to the axle, they also share a fondness for aggressively leaking oil. Fortunately, the source isn't tough to track down, the clean driver's side and soaked passenger side paint a pretty clear picture. Back in Texas, we discovered that this bolt had been slotted to turn it into a breather, which I guess works to allow air movement, but also allows for oil movement. A lot of it. We're gonna swap that out for a thread sealer on a regular bolt, and instead let the axle exhale through a proper breather. I'm pretty sure that this solid bolt holding down the brake hose came from the original Pinto axle, while the Ford 9-inch is meant to use a hollow fastener. We'll pop a hose on the barb fitting, with a vent cap on the other end, and run that up nice and high. Theoretically, the axle can now maintain a steady state of neutral pressure without flinging stinky gear oil all over itself and the innocent bystanders unlucky enough to be in its wake.
There's like little specks of stuff on my windshield.
Now they'll just have to avoid the rolling fog of coolant vapor from the overheating engine that I may or may not have done anything to actually improve.
Just gonna scratch my shit up real bad. And then we can start, nope, let's get the oil pressure sender in there. It's just gonna spray a bunch of oil out, so let's do that first. Oh, that's cylinder number 2, I'm stupid. And I'm gonna drill a hole somewhere in the side. If you see me walking with a limp, it's because I can't stop hitting these damn things sticking through the floor. They must be the seat rail bolts, but they're so long. Why'd they make the bolts so long? First, we need to line this. Well, they're still in there. I'll wipe that off and pretend it never happened.